Hi everyone, this is Dr. Anna and I'm here to do the review for the historical geology final. First of all, your final is going to be 25% of your grade and it is comprehensive from the midterm, so it will include Proterozoic, early late Paleozoic, Mesozoic and Cenozoic. Uh, the format is that I have 100 questions. There are some multiple choice, true false, and of course in the middle the drawings and essay questions. Remember at the end you can write extra credit, which includes anything you learn, but I didn't ask. Remember, 10% of your test is the time scale, and another 10% is the geology of Virginia. In the geology of Virginia, I want you to memorize the different regions like the coastal plain, the Piedmont, the Blue Ridge, and the Valiant Ridges, and put down the age of the rocks there and the types of rocks. So that would be for sure. And now let's go through the chapters. So starting with the Proterozoic, it would be nice if you knew just a little bit about the boundary. But what really is important is right here, the major differences between Archean and Proterozoic. So this 4 is very important. You should know it. Most likely I will ask that. These show you the different Precambrian rocks and mobile belts. You should know what is shield, what is platform, and mobile belts, of course. And of course, we're going to have to talk about Laurentia mostly because that is what includes North America, as you know. Now, we had a bunch of Wilson cycles going through, and this shows you all these building of Laurentia as a large continent. So all these Wilson cycles or orogenies are here. The one we are working on is the green wheel during the Proterozoic. So those are the important things. It's very important that you know the Wilson cycle. It's extremely important. And I already asked it and I will ask it again, so you should know it. The 2 orogeny is the Wapme, which you will have to know. And just a little bit, most of all, that this has the whole Wilson cycle and evidence of every single part of it. And of course you don't have to know the details really. And the other one is the Trans-Hudson. So if you know that these guys show the whole Wilson cycles, you're good to go. Very important, the BIF, the Banded Iron Formation. You got to know what it is and what does it mean. So it's really important. Right here, that's the very important part about it. So they prove that we have shallow water, and it proves that we have free oxygen in the atmosphere because the iron is in oxidized form. The glaciation, we have some in the early Proterozoic. It's not that, but what is important that you know that when we have a lot of red beds, that means that there is dry climate, which means most likely there is glaciation. You should know a little bit about this middle Proterozoic igneous activity. We have no any kind of explanation using plate tectonics, but there is a lot of really important deposit related to this. And as I already mentioned, the green wheel is what's really kind of important because we have the green wheel orogeny happenings in Virginia, and this is what happens there. So you should know the green wheel orogeny more or less. Remember, I already showed you this is the area where you got the green wheel, so Virginia has it big time. And that most likely Laurentia, I'm going one of us together to make Rodinia. You should know that because you know if I didn't ask, you can always just use it as extra credit. So during the late Proterozoic, the Rodinia have broken up, and the continents were drifting apart. So Gondwana went under to the South Pole. So that was set up for a big ice age, as you know. So how do we know that there is an ice age? This is important. You should know it. And of course there are all these explanations: Tillite, the drop stones like you see right here, and of course the striation. The striation is, as the glacier moves over the rocks, it will leave these lines, striations, because the glacier always have rocks, and as it moves through, it carves the rocks. So this shows you the different glaciation throughout Earth history. And as you can see, the Proterozoic glaciation was the biggest one during the Earth history. And this is what shows you. Of course, you don't have to draw this, or you don't have to know where the ice age been formed, but you should know that this was the biggest one. And you just did the internet exercise on the snowball Earth, so a lot of people think that Earth was completely frozen over. Okay, of course you have to know the evolution of atmosphere, how the oxygen formed by photosynthesis, and then of course how the ozone layer formed by UV radiation. This is very important. And some about the fossils. Of course, the cyanobacteria, which is also the stromatolite, very, very important. You should know that they are anaerobic, which means they do not need oxygen, because they produce oxygen via photosynthesis, as you know. They were also prokaryotes, which means they didn't have nucleus. Of course, one cell and asexual reproduction. Most important of these type of fossils are the stromatolites. The stromatolites are like the reefs, basically. They build these structures. And because of the asexual reproduction, we didn't have much of organic diversity. Evolution was very limited because we don't have really variation, nor we don't have mutation. I won't ask much about this. So if you know anything, of course, this one is kind of important. Why the sexual reproduction increased the pace of evolution? That's kind of important. But other than that, I won't really ask any of these things, so don't worry about it much. The Ediacaran fauna, you should know some about it. These are the present day phyla, which might have been presented there. And of course, the interesting part here is the Cambrian explosion, that all the way to the Cambrian there was hardly anything, and then boom, everything suddenly appeared. But in real life it's not really like that, because we had the biggest glaciation stopped, so we had all these ecologic niches, they were all empty, and then, you know, it was at least 15-20 million years by the time all these forms have come around. So to me it's not a big deal. The mineral resources of the Proterozoic, it's quite important. I will have a bunch of questions, but I ask you the mineral resources of certain geologic periods. So that's about the Proterozoic. The next one is the early Paleozoic. And the early Paleozoic, you know, it's important. I already asked in the first test that you got to know the tools we can reconstruct paleogeography with, and explain which one is what somewhat. You had you had problems with this on the test, so it's kind of important. So you should know it. And this here is the early Paleozoic. Remember the Cambrian, Ordovician, Silurian. The Paleozoic paleogeography, you don't really need to know it. I wouldn't know it, so you don't have to. And the important things we're going to talk about is the Laurentia, which is North America, remember, and Baltica, which is Europe. So in between them is the Iapetus Ocean, and North America was on the equator more or less, so it was in the tropics. During the Silurian, we had the Ice Age, so just know a little bit. Important, this guy, Lawrence Sluss. He's the one who come up with the sequence stratigraphy, so know what is sequence stratigraphy, because that's what we're going to talk about. You should know what is apyrexy, and you should know these sequences. That's the thing. I will ask you to please tell me the names of the sequences and their time span. So, like, the yellow means that it's the continent. So at the beginning of the Precambrian, it was all continent, of course. See, everything. And it's a big unconformity. And then as we went toward the Ordovician, almost completely North America was underwater. So this is what it shows. So the Sauk sequence went from the Precambrian to Ordovician, and the Tippecanoe went from Ordovician to Devonian, Kaskaskia from Devonian to Mississippian, and the Absaroka went from Mississippian to the Jurassic. Okay, so if you just know the Paleosequence, you're good to go. So Sauk, Tippecanoe, Kaskaskia, Absaroka, this is important. And then you will have to be able to tell me something about each sequence. So you know that every sequence starts with unconformity, and then quartz sandstone on the unconformity. Then, because North America was in the tropics, you got carbonates. Shale is the peak transgression. That's when the water depth is the biggest. And then as the sea level goes down, you got carbonates coming back, and then regression and unconformity, which is the end of the sequence. So Sauk is the first one, and you don't really need to know the details that much, okay? You just need to know that it's unconformity, quartz sandstone, carbonate, shale, carbonate. So if you know that, and unconformity, if you know that, you're good to go. That's Sauk. Okay, so you don't have to know these details. Good example for the Sauk is the Grand Canyon. And this is the Tippecanoe. In the Tippecanoe, again, it starts with unconformity, the recycled quartz, and so you have to know that that's St. Peter. And then you got a lot of carbonates, shale, which is the peak transgression, and again, the carbonates come back during the regression with lots of evaporates. So as I told you, don't need to know all the details, but just the main things. And this is the mobile belt. During the Sauk sequence time, North America was passive margin, Iapetus was in the middle, and then during the Silurian, we have the so-called Tacony orogeny, so you should know that. And the Tacony orogeny is really when an island arc, just in the ocean in Iapetus, collided into North America. So the beach, instead of being a passive margin, becomes active, and we have a big mountain on the beach and then fallen basin behind. So that's the so-called Tacony orogeny. You should remember that one. And this is how it looked like. So you have mountains at the east coast, which is east coast today, and a big fallen basin behind it, and all the sediment is coming from the highlands. But on the west side, it's still like a Pyrrhic continental sea. These are the mineral resources of the early Paleozoic. You should know them. Don't forget the MBT, Mississippi Valley type deposits. And then this is the explanation for it. So as you can see, I really like the MBT deposits, and so you should know what it is. Now about the life, you should know the most important. Like if you know this slide, you're good to go, more or less. Okay? You do know what is stromatolites, it's important, trilobites, brachiopods, echinoderms. What is Burgess shale, that's kind of important. So that's it. So this here is the early Paleozoic, and now we are on the late Paleozoic, right here. The late Paleozoic, and of course, again, you should know a little bit about the formation of the supercontinent Pangaea, but of course you don't really necessarily need to know all these details, but just like a little bit, I tell you what is important. The Devonian, I won't really ask about this much, but during the Carboniferous, Gondwana moved down south, so we have another ice age here. And it actually really went all the way through the Permian. And during the Permian, when all the continents were together, that is the Pac-Man, I call it the Pangaean time. It's very easy to draw because I could ask you to please draw the Permian supercontinent, to me it looks like a Pac-Man, really, Pac-Man. And then left is Panthalassa, and the right is the Tethys Ocean. So it's easy to do it. This is kind of important to understand that during the Devonian it's all warm. During the Carboniferous it became Ice Age, and in the Permian we have supercontinents. This is an interesting slide, but I won't really ask much about it. It's interesting to know about the oxygen peak during the Carboniferous. Everything was big. Remember, you listened to the slideshow. This shows you the Carboniferous Ice Age right here. And again, now we're going to go through the sequences, and the late Paleozoic is Kaskaskia and Absaroka. You should know that. And again, it starts with the unconformity, followed by quartz sandstone, Oriskany, you should know that. And then carbonates, black shale is the peak transgression, and then carbonates as regression starts in unconformity. So it's always the exact same. Every single sequence has the same steps and same sequence. And you should know the Oriskany has gas in it, and it's a clean quartz sandstone, which is very good for the glass industry, so that's important. It's also good oil reservoir, so it's kind of important. The Devonian Reef is important in North America and Australia. And the black shale. The black shale, a lot of you didn't know the black shale on the test. Black shale means the ocean is stratified. I will ask this, so you should know it. Black shale means stratified ocean. Here is the picture. You have a very oxygen-rich, very, very animal-rich upper layer, and then a completely anoxic, no oxygen, lower layer. So therefore, when everybody dies up here, they go down, and it will not be able to decay. So these are the major source rocks for oil. Okay? Every single time when we have stratified ocean, that means that you have oil shale. Like this is what they do the fracking in. Basically, all of this Devonian black shale is the target for fracking. So you should know this. It's very important. And that just means when you have a stratified ocean, which is worldwide, every ocean is stratified, that means that there are no ice at the poles, because there is no oceanic currents which would mix the ocean up. So this is very important. And this shows you the Devonian black shale complex. It's basically everywhere. And I mean, it only shows half of the US, but it's all over other places too. I'm tired. It's almost 12 o'clock after our class today. That's the black shale. Modern example is the Black Sea. We have no stratified ocean globally today because we have ice at the poles, so therefore we have vigorous oceanic currents. The Black Sea only stratified because it's a landlocked ocean. This shows the very vigorous currents today. This Chattanooga, the Devonian black shale also have uranium in it, so it's kind of important in that way too. And that's the regression of the Kaskaskia. And here is the Absaroka. And the Absaroka, remember, has this Mississippian to Jurassic. When I say Mississippian, it's the latest Mississippian, so it's really right at the beginning of the Pennsylvania. And this is how the Absarokan geography look like. Basically, it's Pac-Man time. This is very important because Pennsylvania is the time of the cycles, the cold cycles. A lot of you didn't know about this. This is very important. I might will ask it. If I didn't, then it's going to be really good for your extra credit. So remember, the cold cycles were formed in this big fallen basin, which was like right behind the mountains on the beach. And imagine, because we had an ice age, we have very, very fast climate cycles, and response to those climate cycles, we had sea level going up and down. So in response to these sea level cycles, basically, you have to imagine, I already told you this in the slideshow, so you should know how these cyclothems are forming. Just think of Everglades. I think I have told you that in the slideshow, so it's there. This is where it tells you what is a cyclotherm. So it's alternating marine, non-marine, deltoid sequences. So we are about in the coastal area, exactly where the coal is forming. This just shows you the cyclotherms themselves. And this shows you. Remember, during the Pennsylvanian, the main plants were ferns. So basically the coal formed from the Sigillarian Lepidolabron ferns. The Carboniferous actually was the time when coal formed all around the world. All the greens are coal formation. So there is a lot of it. Ancestral hierarchies, it's kind of important to know about it. Because of all the collisions, the middle of North America ran uplifted, and it started to erode into the surrounding basins very quickly. And this is when these places like the Garden of Gods in Colorado were formed. And it's all over everywhere. These things happened everywhere. And then later the rivers cut into them. And this is what you see in Arizona, New Mexico, Utah, Colorado. Don't forget to know about the salt dome tectonics. It's extremely important. I will ask questions about it, so you should know what it is. Okay, so all the arches formed by the salt dome tectonics. The paradox basin, remember these are the places where there is oil, so it's kind of important just to know a little bit about it. And then as the Absaroka was regressed, this area, which is very important because these are our main oil reservoirs in the US, and they formed in this reefal, lagoonal, deep basin kind of environment. So right here. The mobile belts, I kind of would like you to know the formation of the Appalachian. Basically, it's right here. So this is the slide you got to know. Starting with the Taconian, which was in the Ordovician Silurian. So Taconian, Caledonian, Akkadian, Hercynian, Allegheny. If you know this, you know your answer for the formation of the Appalachians, okay? And this just shows you basically the Appalachian, and when Europe and America was together, you know, on the European side we have the Old Red Sandstone, and on the American side is the Catskill Delta. Oh, gosh, I'm tired. These are the mineral resources, and you should know it because I might ask you. This is the petroleum and natural gas, the coal, you know. Of course, you don't need to know every little details, but you should know that oil reservoir is important, the coal is very important, and this is just the life. Just a little bit about the life you should know. Like the Devonian is the age of fish. It's very important. If nothing else, you should know that. And so that's it. It's important because the amniotic egg comes around, and that's what lets animals go to the dry land, because these eggs are able to stay alive in those kind of environments. So this here is the Permian mass extinction. Just make sure that you understand that this is bigger than the one at the end of the Cretaceous. So that's the late Paleozoic, and I'm going to continue with Mesozoic in just one sec. Hey, so the next chapter is the Mesozoic, and the Mesozoic, of course you have to know Triassic, Jurassic, Cretaceous. You have to know that the important events is the supercontinent at the beginning of the Mesozoic, and then breaking it. By the latest Cretaceous, all the continents look almost like today. You know that the Mesozoic is warm, of course. You have to know something about the supercontinent climate. You got to understand what do scientists think about the extremely high sea level in the Cretaceous, and what are the possible causes for that. If for some reason I didn't ask that, you can always look at use it as extra credit. Just a couple of things about the breaking up of Pangea. I won't ask details, but just a little bit, if you would know the stage is just a little bit. It's, you don't have to focus on that really. And it's interesting to know about India that by the end of the Cretaceous, it just then reached the equator. It's kind of interesting. We are not following the sequences, so you should go like I did, starting with Eastern North America. Here you got to understand the rift basins and all the sediment in the rift basins. That we call this the New York supergroup, that it shows amazing cyclicity. With the smallest 20,000 year cycle, like the Van Houten cycle, and that's a lake level change, because we know these rift basins were lake level. And then that these cycles actually have a major sequences, like we have the one which is 20,000, then the 100,000 with 1, 2, 3, 4, 5 low cycles, and then there is a 400,000. So this is very important that you understand that there is a major hierarchy of these cycles. What are the rift basins? What kind of sediments are in there? They're famous for the dinosaur steps. And they are all there, even though they are not completely on the surface, they are still down below the sediments in the Atlantic Ocean. In the Gulf, you should know just a little bit about the Gulf, the Sodom tectonic, remember we already mentioned, and what does it really do, and how it helps with the oil reservoirs. It's kind of important. That the corals have died out and they were replaced by rudists. And the western, I really won't ask much about the western regions, but you should know that everything pretty happened during this time, and it's because of the Pangean time, extremely continental arid climate, and all these red sandstone were forming during this time. I absolutely will not ask these formation names. And it's interesting. The only thing I might ask is the Morrison Formation, because that was that's the dinosaur formation, and most of you like the dinosaurs. And I won't ask the tectonics either, because it's kind of complicated. We have all these orogenies, so I won't really ask, because you should know about the batholiths. These are the big batholiths, as oceanic continental plate boundary on the west formed all these granite batholiths, and all of our gold and a lot of metallic deposits are related to this, so you should know that one. And then the mineral resources, of course, you should know the metallic minerals, the gold, copper, and then the non-metallic, starting with the diamond. Remember, the diamond forms in these kimberlite pipes deep down at the continental breakup. I have talked about the salt from the Gulf of Mexico, of course, and then all the energy resources. We have the nuclear ones, we have the fossil fuels, coal and oil, and the Mesozoic life. I will not ask much about it, so you should know a little bit, but you don't have to focus much on that one. And then we go into the Cenozoic, which is the last period. It's easy from here on. You should know, of course, you already know the Paleocene, so you're good on that, and you know the Tertiary and the Quaternary. The Cenozoic plate tectonics, everything gets to where it is today, and I mean, you don't have to know details about it. You should know this because we learned it in plate tectonics everywhere. You know, the divergent plate boundary around Africa, the Gulf of Aden, the Red Sea, and the East African Rift Basin. You should know that these guys are the failed arm of this system. as I mentioned it before. The two major orogeny belts, you should know. And of course I have all these details, which I mean, the circum-Pacific orogenic belt. So this slide is kind of important, that the eastern margin is all oceanic continental, the western margin is mostly oceanic. The Gulf coastal, you have to know about these deltaic sequences. It's kind of important, and the formation of the oil, kind of important. But definitely you got to know the different oil traps, the stratigraphic and the structural. Stratigraphic is those river things, I drew it on the slideshow. In the structural, you should know the anticline, the fault line, the salt. At least these three you should know. Here are the salt domes, and then had the video exploration with the seismic surveys. How can they do it? It's kind of interesting. Of course, I will not ask much about this, you already know. Florida, you should know a little bit about Florida. Like this slide probably is quite important. And everything in Florida, because it's in the tropics or subtropics, every living thing producing actually carbonates, famous for the bones. Again, the Cordillera, I won't ask too much about it, so you don't really have to. Of course, you understand San Andreas Fault and all that. Eastern North America, you should know more because it's right here. It's a passive margin, so this slide is kind of important. And that all the sediments is going from the Appalachian into it. These are the things you can find. The meteorite would be interesting, the late Eocene meteorite, and all the evidences. The Cenozoic climate is kind of important. What can we use for climate studies? So the leaves, the oxygen isotopes, these are important, you should know. It's important to know. The ice cores, so you should know this. And somewhat about the Cenozoic climate. So you should know that the Eocene was completely warm, and then this dramatic change, and the reason for this is because Antarctica and Australia separated and Antarctica moved to the South Pole. So this is kind of important. And there is this cold current around Antarctica, so the ice starts building, which actually lowered the sea level big time, and the Mediterranean dried up. So this is the Messinian salinity crisis. In the Mediterranean Sea, there is a lot of salt deposits also. Resources of the Cenozoics right here, and I will not ask anything really about the life. So here is the Quaternary, which is very important. This is 100% question. What do we need for the Ice Age? Remember, they have to have continental pole, know something about the albedo and the icebox effect, the cold current around Antarctica. The cyclicity, how do we know it exactly? What happens during interglacial and glacial time? And you got to know the Milankovitch theory. The three things: eccentricity, obliquity, and precession. These are important. The precession is the 20, obliquity is the 40, and the eccentricity is the 100,000 year cycle. So this is what defines the sea level, the climate on Earth today. So the Quaternary, we know that there is a lot of 20,000 year cycles based on the oxygen isotope studies. That's what we really can use. Because on land all you have is tillite, so you cannot really separate them. So on Earth they only have 4 major glacial. However, if we use the oxygen isotope studies, we have 14 to 16, and the ice core suggests the same. And remember, this is just the very last 125,000 years. I won't really ask much about it, but it's interesting. You can see that there are smaller cycles, which we don't really exactly see in the rocks, but you know, from historical measurements, we know that they are there. And of course, I won't ask anything about this, but it's just kind of very important. What kind of evidences do we have that the sea level goes up and down a whole lot? We have these terraces along the beaches, and of course the blue hole. And the blue hole, as you know, is sinkhole, which has stalactites and stalagmites, which got preserved because they are sitting in 8.2 pH, which doesn't dissolve the limestone. So these guys are completely preserved. So that's about it, and I hope that you will do really well on the test, and I wish you the best. See ya.